Ideally, one screen pixel maps to one of the texels in the texture image already loaded into the texture memory buffer. Let me show you an example. For example, if this is our bitmap right here, and our object is exactly the same size in terms of the pixels, which what we would call this ideal situation, each pixel maps exactly to one texel inside this texture image. On the other hand, we could have a different situation. For instance, our bitmap can be quite small, so this one is like 24 by 24 pixels only. But if the textured object appears to be much closer to the viewer than this visibly small bitmap, like this, so the actual object is this size, and we apply this bitmap to it, it's sort of compared to the size of the original bitmap, or this original image has to be magnified, and this is what we call magnification. Basically, this is like zooming in into this original bitmap texture. So the result of this magnification is that multiple screen pixels, which are located next to each other on the screen, start to map all together as a group, start to map to just a single texel in the original texture image. So we call this situation magnification. So let's bring back the original image right here, which is a larger image, but at the same time, if the object moves farther away, which is what we call minification of the object, a single pixel on the screen starts to sample many texels in the texture image. Right, so in this situation of minification, right here, if the object is much smaller, like this size only, then a single pixel starts sampling multiple texels in the original image, like this, right? So all these texels right here just simply map into one pixel over here. So OpenGL has additional preferences which we can set to handle both of these situations. To handle minification and magnification properly, we can specify additional texture preference such as magnification filter and minification filter as well. So the filter can be GL nearest, which returns the nearest single texel from the texture sample location in our texture object, or it can be linear, which enables linear texel filtering like this. So currently this example project is using the nearest texel filter for both magnification and minification situations. So let's change to this 24 by 24 very small bitmap, which I call bricks. Okay, and try loading this filter. And just see how this looks like with this GL nearest setting right here. Okay, so I'm just going to run this program. And so there, so this is the original image is really small, or just appears to be physically this size. So obviously we have this magnification, and this magnification is using the GL nearest filter to magnify what's there in the image. So now we can try this linear filtering and see how that changes the appearance of our rendering of the texture. Just run it again. And so yeah, this is an example of the linear filtering. So these are the options that we can consider. And in addition to the idea of using filtering, there is also mipmapping. And in case of mipmapping, we may choose to use a larger texture. But as the textured object moves farther from the viewpoint, so we begin to experience minification of this image, the ratio of pixels to texels becomes very low, and the texture ends up being sampled at a very low rate, producing obviously very low quality rendering. So to better handle texture minification, we can alternatively use mipmapping. And mipmapping is simply generation of lower resolution images of this. And it's a very simple OpenGL call. It's just in addition to what we already do with our textures, we can call generate mipmap and specify the type of texture that we're using. And so here, this is an example of mipmapping. So OpenGL will automatically pick the most appropriate image to interpolate when the texture minification is happening. So when we experience minification of this image, then OpenGL automatically will pick one of these pre-filtered images, which are automatically generated at the ratio of 1/4, then 1/16, and so forth, up to a single pixel. Our next laboratory project will have an example of this mipmapping of the lower resolution images.